Okay, so this is the last section of Chapter 12, and then, the rest of the week will be in Chapter 13, which is kind of the last major chapter we do in here this semester. So we're only got 3 weeks left. You guys realize that? And it's all over. So what I'm going to do on this, so these are guidelines. I'm not going to really read these things off. These are kind of general guidelines you're going to go through when you do these problems, and I'll be kind of talking through these as I go through an example. But what an optimization problem is you have some sort of scenario, and you're trying to find something that is optimum. Okay, so you might find what is the optimum price to charge in order to maximize a revenue or something like that. Another thing that you do, like in industrial engineering, we're going to do a problem like that, is you might want to figure out, maybe you're packaging cereal, and there's a way to minimize the cost of the package, or there's a way to maximize the amount of cereal that'll fit in the box by minimizing the cost. Now that would be something that somebody would look at, okay, because you're trying to maximize how much money you're bringing in. Things like that make a difference. So we're going to look at some problems kind of like that. We're going to start with just sort of generic problems that'll help you get an understanding of the idea before we do anything else, though. Before we do economics and stuff, we're going to start with this. So to begin with, let me explain what this problem is saying. This problem is saying that you're going to find two numbers whose difference, and difference, what does that mean? It just means you're subtracting, okay? And then the product is at a minimum. So what I'm going to do, before I do the problem, I want to just have you write a couple of things down to help you understand this, okay? So for instance, you got to have two numbers that when you subtract them, you get 100. One possibility would be 100 minus 1. Okay, let's write that down. And then if you did 100 times 1, you would get 100. Okay, what you're doing is you're trying to find, hold on, that's not right. Let me correct myself there, I just got that. Let's do 101 minus 1. Okay, that would be two numbers that have a difference of 100. Now if you did the product, which means multiply, you would have 101 times 1, so that's equal to 101. Okay? Now let's just go through a couple more here. Let's say you had 102 minus 2. Well, that's 100. But if you did 102 times 2, if you did the product, you'd have 204. So see, that product's going to change. Okay, and then you could go on and on and on and on. You may end up with something like, you could have 401 minus, what would that have to be, 100, 301, right? Okay, that would be two numbers, right? And those two numbers have a difference that's equal to 100. But if you multiplied 401 and 301, you would get something real big, okay? So the point I'm trying to make on this is, it looks like the bigger these numbers get, the bigger the product gets, okay? So we're trying to find the numbers, and they can be negatives also, where this product is going to be in the minimum. Now, so far, just by kind of thinking through the problem, that's where my minimum is now, but that's not the answer to the problem. We're going to figure it out using calculus, but that's the idea. So you're looking at two numbers that are 100 apart, but their product's a minimum, and we can have negatives. I didn't say in the problem you can't have a negative number. So what you try to do on this is you kind of start this way. You got to kind of come up with some sort of an equation. You draw a picture if you need to. You don't really need to in this problem. So here's what we're going to do. We're going to just kind of list our variables. So let's let, for step 1, let's let x be the first number. And then let's let y be the second number. So you've got to kind of figure out what your variables are in the problem. And then the key is to try to figure out an equation or two and a function that you're going to minimize or maximize. Okay, so let me see if you guys kind of can give me an equation. Well, what are we doing here? What are we doing? A number minus a number is 100. So what would be an equation? If I've got this as x and that's y, then what would you get? X minus y equals 100. Okay, that's an equation that's important. Okay, and you could do it backwards. You could do y minus x is 100. It'll still work. Okay, so you have that. Okay? Now, that gives you an equation, but that's what you want to do is you want to figure out what you're minimizing on this. So the key thing on this is you want to express with one variable, the function with one variable. Now, we're not quite done yet. So the function is going to be, now what are we trying to minimize? We're trying to minimize this, right? Okay, we're multiplying the two numbers. So we're going to minimize x times y. So you want to write this kind of like this. Now, x minus y is 100 is an important equation. But we have a function. You've probably never seen this before at any point in your life. You can have functions of two variables. So I'm going to have you write that as f of xy equals x times y, just to start with, okay? Because you might encounter that. I mean, if you're going to study like economics or something, you will start encountering functions of more than one variable, okay? So this is what you're going to take a derivative of, is this thing right here. So this is what you're going to differentiate and what you're going to find critical numbers on. But you have to express that with one variable. Okay, so watch carefully. What you want to do is you want to take this equation and you want to solve it for either variable. It doesn't make any difference. What I'm going to do is just move the y to the other side so I get x equals y. It's now positive y plus 100. Okay, now what you got to do, remember, you can't take the derivative of xy until you get it down to one variable. That to me is the most important part of these problems when you're learning it. So what I'm going to do is this right here is going to get replaced with y plus 100. And then that way you'll have a function that has one variable in it. Okay? Typically in these problems you have a function that you're going to do a derivative, and then you have an equation that relates those variables in some way. Okay, so what you're going to have now is you're going to have f of y. Now replace this x I highlighted in yellow with y plus 100. Then you still have that y like that. Let me pause there and kind of tell you what my thought process is. So the first thing is, the question in the problem said the product is a minimum. What's the product? It's xy. And whatever I'm wanting you to minimize or maximize is what you do a derivative of. You don't want to do a derivative until you have what? One variable. So what I did is I took this equation, solved it for a variable plugged in. Now notice my function has one variable. This is what you want to do a derivative and set equal to 0. Does that make any sense? Okay? You're not going to differentiate something with two variables. It needs to be one variable only. Okay? So here's what we're going to do in our third step. And you could solve that for y. It doesn't matter if you solve that equation for x or y, you still get the same answer. So this is going to be f of y. I'm going to do a distributive property to get y squared plus 100y like that. Okay, now that derivative is going to be simple. So we're now going to get into finding critical numbers. And I'm following the directions. I got a primary equation, which is x minus y is 100. Then I got the function, which is this. When you go to this step, you want to get one variable. We've done that. Okay, now the domain is all real numbers. So basically, this problem didn't say that you had to just have positive numbers. So it can be anything. Okay, step 4 is you want to use calculus to find the answer. So next thing we want to do is just do f prime of y. So that's 2y plus 100. You're going to find critical numbers. Okay, so when we find the critical numbers, you want to set that equal to 0. Okay, you got your derivative, set it to 0. Solve the equation, so that's 2y equals negative 100. Divide by 2. So one of the numbers has to be negative 50. That's one of the numbers. That's one number. So then what you got to do is you got to find the other number. So that would be one answer. Okay, and then the second thing is just go to your equation, which is x minus y equals 100, and then replace the y with negative 50 to find x. Okay, and then you'll have your two numbers. So we're going to have x, be careful here, minus negative 50 is equal to 100. Okay, like that. Okay, you got the minus minus, so that gives x plus 50 equals 100. Okay, in your head, what's the answer? 50. So x is 50. Okay, so it turns out that that would be where your minimum occurs like that. So that means the answer to the problem would be this. It would just be 50 and negative 50. And that would actually give you the minimum product if you did that. And then if you did 50 times negative 50, you would get negative 2,500. So that is the minimum product you can get out of two numbers that are 100 apart. Okay, the other thing I want to ask you is, how far apart is negative 50 and 50? How far apart are they? They're 100.
Furthest, right?
Yeah, they're 100 apart, right? Okay, but when you multiply them, that is as small as it'll ever get. The reason is because one of them's negative, okay? One of them's positive like that, okay? Now that's the idea. So these things take a little time to catch on to, but the thing that you got to do on this is you're always going to have a function that you got to get down to one variable, and you almost always have an equation that allows you to do that. Then once you get that, the whole key to the problem, the hardest part of the problem for students is getting to this. Once you get there, you're not going to have much trouble with it, seriously, because what do? You do a derivative, you set it equal to 0, you solve, and if your derivatives are pretty simple, it's pretty easy to do. Okay, so that's the idea. So I want to have you do something on the graphing calculator on this too. So what I want to have you do is we're going to put in the function that we're doing a derivative of. And the function that we did a derivative of was this thing right here that I kind of circled in green. So we're going to use x. So let's do like x squared plus 100 times x like this. The other thing you can do is you can verify this on a graphing calculator. So let's go ahead and let's do, since we had 50 and negative 50 were those numbers, for our window, let's go ahead and let's do something like, just so you'll see this, I'm going to go negative 100 to 100, just something that will get these two numbers in here. And then maybe scale that by 10. Our minimum product was negative 2,500. That's the minimum of y. So for what I'm going to do for my y's is I'm going to do like maybe negative 3,000. And then for my max y, I'm going to do just 3,000 or something like this. Okay. And this is a good way to kind of make sense of your problem is by doing this. So I'm going to slide that over there. Then I'm going to graph this, and I'll show you what we get. So what you'll see is you clearly got a minimum, right? Very clearly you got a minimum. That minimum occurred at negative 50. That's where y was negative 50. So if I trace at negative 50, it'll point out that that's where that minimum is. So what's happening on this problem, and an easy way to interpret this, if you know anything about Excel spreadsheets, sometimes when I teach this information, I'll show you a spreadsheet. But really what it means is if you opened up and went second table, all it means is if you took x and multiplied it by the corresponding y, you're going to end up getting a product. This is the product right here. That's what that is. So if you just kept going through that table, eventually it's going to hit that low point. So eventually I'm going to get down to the negative 2,500. Sometimes this thing can't keep up with my fast hand here. So eventually you'll hit that, and you'll notice on this it's going to start going up again. Okay, right there. Okay, once I get into the negative 50, it's going to hit its low point, and look what happens. Okay, so that's where you get your minimum product, and see how it gets bigger and bigger. Does that make sense?
Oh, I see. And then like the negative 51, it's getting smaller.
Yep, exactly.
Okay.
Now see right there, that's the smallest number you're ever going to hit. And to the right of that, it gets bigger. To the left of that, it gets bigger also. That's what the graph showed. So that's it. So you can actually, if you know something about spreadsheets, you could set it up so you just have your two numbers that are a difference of 100, have a column where the product, and you'll find negative 2,500 is where it happens. Okay, does that make any sense? Okay. Okay, these problems can be a little rough to learn. They can. So I'm going to do the next one here. Before we do anything that's got business applications, I want to do some things with geometry and numbers because you want to kind of get the idea. So this second example, okay, the problem says you're going to find the dimensions of a rectangle that have this area. Yeah, but that's a given. The area is 1,000 square meters, but the perimeter has got to be as small as possible. So what I tried to do on this is draw different rectangles. Okay, you could have, for instance, one possibility might be you have 100 meters and you have 10 meters. Okay, how do you find the area of a rectangle anyway? You just multiply base times height. So this area would be, it'd be 1,000 square meters, right? That would be one possibility, okay? Now that perimeter, what does perimeter mean? It means the distance around. That's a pretty big perimeter, okay? That's pretty big distance. Okay, another possibility might be you have 1,000 meters here. You have 1 meter there. Wouldn't the area still be 1,000? Okay, is the perimeter big or small? Is real big because you're stretching it out. Another possibility might be these things are the same, okay? So if you did that, you would have, I don't know what that number would be. It'd be the square root of 1,000, whatever that is. I'm going to do that on the calculator because I'm wanting to kind of give you a visual idea of what this problem means. So if you did like square root of 100, that's going to be decimals. And that would be, oh, no, square root of 1,000, I'm sorry. Putting the wrong thing in. So square root of 1,000 would be like about 31.6. So you might have 31.6 and 31.6. Okay? That perimeter there would be smaller than that perimeter, right? Okay? So the idea, what I'm trying to get you to see on this is there's all kinds of ways. There's an infinite number of rectangles that have a area of 1,000, right? But there's only one that will minimize the distance around, okay? So we're going to find what that number is. So the first thing is, draw a picture. I've already done that, but we're going to draw a picture and label stuff. So step one, let's just draw a rectangle. And let's label, you can use whatever variables you want. You can use X and Y. You could use L and W, whatever you want. So we're going to start that way. Okay, step two, we're going to see if we come up with some equations. Okay, first of all, if you want to find the perimeter of this rectangle, okay, how do you find the perimeter of this rectangle? Just add everything up, okay? So the perimeter would be, and this is going to be a function of two variables, would be x plus x is 2x, y plus y is 2y. That's what you're going to differentiate. That's what you're minimizing. The problem says the perimeter is as small as possible. So this is what you're going to minimize. But you can only do that if that's in terms of one variable. Right now we got two variables. We can't have that. So there's another equation. Okay, the area, how do you find the area of this rectangle? X times y. Did I tell you what the area is? 1,000, I told you. So that means you have 1,000 equals xy. So here's what you have. Typically in these problems, you're going to have a function that you are going to do a derivative of, and you're going to have a function that relates the two variables, almost always, without exception. Okay? So what we're going to do on this is we want to take, when you start getting into your third step, you want to make sure that this function only has one variable in it. So you want to take this equation and you either solve it for x or y. It doesn't make any difference. And what I'm going to do in this case, I'm just going to solve it for y this time. But it's your call. So I'm going to divide both sides by x. And that's going to give me y equals 1,000 over x. Now what I do with that is I take that and I plug it in to the y of the function, and that way my function that I'm going to do a derivative has one unknown. That's the biggest part of the problem. This is the hardest part of the problem for students, is step two, getting everything together. So what you're going to have is p is equal to, you're still going to have 2x, but now you're going to have 2 times y, and y is 1,000 over x like that. How many unknowns does that have? It has 1. Okay, so we're ready now. This is what we're going to work with the derivative on. Now, we ultimately got to find x and y, but if we're going to minimize, we got to do the derivative of this function. Okay, so here's what you need to tell me if you understand. Does everybody understand that 2x plus 2y is the perimeter of that? Okay, does everybody understand that the area is xy? And I gave you the area is 1,000. So what I'm doing, see, is I'm solving this for a variable, plugging it in so that I only have one unknown in my function. Because you don't want to do a derivative unless you got it down to one unknown. So now we're ready to do the calculus, okay? We're all set up. So we got P of x is equal to 2x. Now I'm going to just multiply this out, and that would give 2,000, and it would be wise to move that to the top so you could do a power rule. So that'd be 2,000x to the negative 1 like that, okay? Now, if you're looking at kind of the domain on this problem, well, x and y have got to be positive numbers, okay? I mean, those things have to be positive numbers, okay? They have to be. That's the only stipulation in the problem is you have that for now. So let's do p prime of x. So that's going to be the derivative of 2x is 2. Do a power rule here to get minus 2,000 x to the negative 2. That's your first derivative. Now, what do you do with that? You're finding a critical number, so you set it to 0, and you look where it's undefined. So you're going to have 2 minus, and I'm going to write this as 2,000 over x to the second is equal to 0. Okay, like that. Now I got to solve that equation, and that will give me a critical number. Then we can see if that's going to be a minimum. Okay, so I'm going to solve this way. I'm going to move this to the other side to get 2 is equal to 2,000 over x squared. Okay, I can now multiply. You can either cross multiply or you can multiply both sides by x squared. Okay, that's going to leave you with 2x to the second is equal to 2,000. Okay, now what do you need to do to finish this solving?
Divide by 2.
Divide by 2. Square root, good. So I got x squared equals 1,000. Okay, now I do square root of both sides. Now I don't need to have a minus because a minus makes no sense on this problem because you're talking about a dimension of a rectangle. So what you would have then is you would just have that, and we can go ahead and round that. I did that a minute ago. Wasn't that was like
31 point something?
31.6. Okay, yeah, that's an approximate answer of the problem. That would be it. Okay, well, we got to find both dimensions. So we got that. So we would have x equals 31.6. Then you also got to find y. So the easiest way to find y is from this equation right here or this one right here. Okay, so I'm just going to use this one I highlighted in blue. So I'm going to have y equals 1,000 over x. Now you can plug in x. So you have 1,000 over 31.6, which I think is also 31.6, approximately. So I'll do that. Okay, and yeah, that's what I thought. Same thing. So you also get y equals 31.6. Okay. All right, so here's how you would write the answer. You would basically just say the dimensions of the rectangle are 31.6, and this was what, in meters? So it'd be 31.6 meters by 31.6 meters. And I'll show you kind of how you can make sense of this with a graphical technique. Okay, now again, the big part of this problem to me is the whole key is getting to that third step when you're ready to differentiate. That's the hardest part of the problem for most students is setting up that function that you're going to differentiate. And once you do, you're going to differentiate, set it to 0, and do that. Now, if you want to determine if you're right on the problem with technology, which I would want you to know how to do, graph what you took a derivative of. So graph the function. Don't graph anything else, just the function you did a derivative of. So that is 2x, and it's really 2,000 over x. Okay, like that. I'm putting this in, 2,000 over x. Okay, if I graph this for a window, the only thing that makes sense is the minimum of x is 0 because you're talking about dimensions of a rectangle. We found the minimum to be 31.6, so I'm going to just use like 50 here, just as long as it's bigger than 31.6. Okay, and then for my area, the biggest area was 1,000. Okay, so if you went to kind of look at your table of values, this right here is basically giving you minimums like that. So I'm going to put in like 0 to 1,000 or something like that just for Y. I'm going to start off that way. I guess you don't have to put this on calculator. I just want you to see what I'm doing here. Okay, so if you kind of go through and look at this now, okay, I just graphed what this is. And what I did is I looked at going out to 100, and that was going up to 1,000 like that. Does this thing look like it has a minimum? It actually is going to start increasing. You can't see it very good. But that's kind of where the minimum is right there. So what you could do is you could trace at 31.6. That's right. Okay, visually. Okay, it'll look better if I take the window out further. If I took that out to, 100 or something like, instead of 50, it'd look a little bit better. It'd be a little bit clearer to see. That's it. Okay, so we got a minimum and we found it. Okay, so what happens on this problem is it turned out to be a square. Okay, that's what minimized the distance around. Is that logical to you? Now, it's not always that way, just depending on the conditions of this problem. The way to make the distance around the smallest is to make it into a square. Not stretch it out like I did there, but make it a square. Does that help some? Okay, so that's what you're doing. Now, like in the world of economics and industrial engineering and factories and stuff, yeah, people might look at, I want to package stuff in a way that minimizes the material. Okay, you wouldn't want to make a cereal box that's like long and stringy, right? You kind of make it, they also don't make it into a perfect cube, although they could, just I guess because it's kind of bad, it's hard to hold. So they make, different concessions like that.
You
okay,
probably can't stack so many on the shelf.
Yeah, there's things like that. But if they really wanted to minimize the amount of material on a cereal box, they would make it into a cube. So your Captain Crunch or whatever would be in a cube, not in a rectangular box. But there's other considerations. Okay, let me give you back your tests, and then we'll be done for today.